Hello, class. We're about to start lesson 1-6, relatively speaking. And according to our syllabus, we need to do page 70, problems 1 through 8, and also page 73, problems 1 through 15. Okay, so now we need to look down here at the bottom of page 69 before we actually get to page 70. We need to look at these formulas here. We have regular difference, which is just the new value minus the old value. And then we have relative difference. Now, relative difference deals with the new value minus the original value divided by the original value. And then also with relative difference, a lot of times we would change that to a percentage. So now that is very important as we move on to this lesson here. So let's move on to page 70. Okay, now it says here on page 70, find the relative difference if you win $5 million and get shorted by $10. Write as a fraction, not a decimal. Okay, so if you won $5 million, but you only received $4,999,990, which is the $10 being short, what you would do is your new value would be the amount that you would get that you were shorted. The original value would be the $5 million. And you would divide it by the $5 million. So this will give you a negative 10 over the 5 million, which is what it means to be shorted by that value. Now, they told us to write as a fraction, not as a decimal. And if you divide this out, both of these have 10 in common. You could put in your calculator. It'd be negative 1 over 500,000. Now, they ask us here to convert your answer to question 1 into a percent. So let's do that. We'll put it on our calculator. And we will have, we know that our answer here was a negative 1 over 500,000. So it'd be a negative 1 divided by 500,000. And if you notice, we have a very long number here. So let's write that decimal out. Negative 0. What's that? 5 zeros and a 2. Okay, so now we want to change this to a percent. When you change this to a percent, we know we'll move the decimal 2 places to the right and put a percent sign at the end. So it'd be negative 0.0002%. That's the relative difference as far as the percentage goes. Now, number 3. It says compare the relative differences for the two scenarios in an opening paragraph from this lesson. Does this match your intuition about the scenarios? Yes, it does. Because think about it, getting short $10, we know that that is not going to be that significant for $5 million. All right, so now we go here to number 4. It says both Shauna and John found out that they're getting a $1,000 annual raise this year. John went out to celebrate, while Shauna yawned and said, "Yeah, whatever." Use the topic of this lesson to describe what you think might be likely to account for this discrepancy in their reactions to the news. Well, I would just say this. Of course, this is my opinion, but John had a significant raise in salary, and Shauna did not. So that's my guess as to why the reactions were totally different. Now we go here to number 5. Now, with number 5, it says your instructors tells you that you're going to get an additional 2 points on a recent test or quiz. Describe when this would be great news and when it wouldn't help. Okay. Now we know that in this class you need a 70% in order to pass the class. If that takes you from a 68% to a 70%, you pass. But if this takes you from a 4% to a 6%, it is still not a passing grade. Okay, number 6. The U.S. federal budget deficit for 2011 was about $1.298 trillion. This means that the government spent almost $1.3 trillion more than it took in. If you round that amount up to $1.3 trillion, which seems perfectly harmless, you cost the taxpayers of this country $2 billion. Thanks. What's the relative difference between the actual amount and the higher rounded amount? Hint, if you're clever, you won't need to work with huge numbers. Discuss whether or not you think this difference is significant. It's up to you to decide and defend what you think significant means in this context. Okay, so we know we're doing a relative difference. And the relative difference here would be the estimate minus the actual divided by the actual. Now we know we're used to dealing with new minus original divided by original, but the estimate would be your new value. The original would be your actual value. So the estimate here would be 1.3 billion. So we could just put everything in billions. So it'd be 1.3 minus the actual, which is 1.298, divided by 1.298. So when we subtract this, this would give us 0.002 over 1.298. Now, we put this in our calculator. We have 0.002 divided by 1.298. Now, if we round this, we go like, let's just go 4 decimal places. 0.0015. Okay, now, since we want to write this, we have to write this as a percent. So it'll be approximately 0.15%. Now, we're asked here, it says discuss whether or not you think this difference is significant. It's up to you to decide and defend what you think significant means in this context. Okay. It would just depend on what you mean. Like it was told to us in the directions that estimating it would cost us $2 billion. So if you're looking at the actual dollars, it's significant. $2 billion. I mean, last I checked, I didn't have $2 billion in my bank account. Now you may have it in yours, but $2 billion is a significant amount. But if you look at it from a percentage standpoint, this is less than half. Matter of fact, it's just slightly over a tenth of a percent, which is very, very small in comparison. So it would just depend on your perspective. So now, we look here at number 7. It says a college football team won 5 games and lost 7 in 2014. Then turned around winning 7 and losing 5 in 2015. At the same school, the basketball team won 10 of 34 games in 2014, then won 15 of 34 the following year. Which team had the more significant improvement? Discuss and back up with evidence. Okay, so first of all, we know 2014 comes before 2015. So we know this is original and this is the new. And the same thing here. This is original and the following year would be 2015, so this would be new. So we'll do the relative difference, and we know it's still new minus original divided by original, and we'll do it for both. New minus the original divided by original. Okay. So we could just say that this is F for football and basketball, B for basketball. So we'll designate which is which. So the new value here for the college football, and we're talking about the winning. So they won 7, which is new, minus 5, which is old, divided by 5. So this would be 2/5. You put in your calculator to give you 0.40, which as a percentage, it'll be 40%. So that's what the football team, they went up 40%. Now the basketball team, the new value was 15. The original value was 10 divided by 10. So this will give us 5/10, which is 0.50, which we know is 50%. So it says, well, so we know the basketball team had a more significant increase by 10%. And that is our final answer for number 7. Now, we move on to our next page to do problem number 8. Now, number 8, it says in my Calc 2 class yesterday, we were doing approximations of various outputs using advanced calculus techniques. Anyhow, in one case, the approximation was 1, while the exact value was 0.406. In another case, the approximation was 21, while the exact value was 22.176. Which was the worst approximation? Use the techniques we've used. So, we're going to do the relative difference. Let me see. Okay. For both. And we know it is the estimate minus the actual divided by the actual. And we're going to use this formula for both. Estimate minus actual divided by the actual. Now with the first value, the estimate was 1, or approximation, which is an estimate, minus the exact value, which was the actual, divided by the actual. And then the second value here, the approximation or estimate was 21. The exact was 22.176 over 22.176. Now, when we subtract here, it'll give us 0.594 all over 0.406. And here, when we subtract, it will give us a negative 1.176 over 22.176. And so here, this will give us 1.46, which is 146%. Here, this will give us a negative 0.053, which is a negative 5.3%. Okay, now, no, sorry about that. Okay, now, if you notice here, this this went up by 146%. This only went down by 5.3%. So basically, they asked us which was the worst approximation. The first case was the worst because it overestimated by 146%, whereas the second case underestimated by 5.3%. Now, I would say this, because we're talking about a calculus class and basically approximations in that class, is not, this case scenario is appropriate to say it this way. But if we were talking about real life situation, just like for instance, we're living in the age of the coronavirus. Okay, now I believe everyone would be okay if we overestimated, say we got the cure. If we overestimated the cure by 146%, like having a surplus, everybody would be okay with that because we could use that for future uses. But then if we were short 5.3%, that could be hundreds of thousands and millions of lives that could be affected by that. So it just depends on the scenario, but based upon this scenario, this would be a good conclusion to have. Okay, now we go over here to page 73 for the next part of section 1.6. It says here, using professional guidelines, an installer estimated that 24 and 2/3 square yards of carpet would be needed for the bedroom and closet shown in the diagram. Recall that the area of a rectangle is length times width. So, number one, find the area of the bedroom only in square inches. Okay, so we'll take the area is equal to length times width. The area would be 171 inches multiplied by 138 inches. Now when we multiply this out, it would give us 23,598 square inches, because inches times inches is square inches. Now, we go on here to problem number 2. It says find the area of the closet in square inches. Now the area, again, we know is length times width. The length would be 64 inches, and the width is 50 inches, which we see here. So when we multiply this out, that'll give us 32 inches, 32 square inches, 3,200 square inches. All right, now, it says each of the doorways shown is 32 inches wide and the walls are 4 inches thick. Carpet is needed for the entire doorway between the bedroom and closet, and a half of the doorway into the bedroom. How many square inches does this add to the total carpeted area? So we have 32 inches times 4 plus 32 inches times 2. So when we multiply this out, this would give us, multiplying that, it'll give us 192 square inches. Now we move on to problem number 4. It says we know that there are 36 inches in 1 yard. How many square inches are there in a square yard? The diagram below should help. Okay, if we look here, we have 36 inches is equal to 1 yard. Because remember, it's 3 feet in a yard. And so if we change 3 feet to inches, that's 36 inches. All right, so now, if we square both sides, take both sides to the second power, 36 square inches, well, inches squared, will give us 1,296 square inches. And that would be equal to 1 square yard. Okay, so now that's telling us it takes 1,296 square inches to equal to 1 square yard. Now we come here to number 5. It says use the conversion factor you developed in question 4 to convert the total carpeted area to square yards. Round to 1 decimal place. So what we need to do is take our values that we had earlier, the 23,598, the 3,200, and the 192, and add all of those together. That'll give us 26,990 square inches. Now we want to change this to square yards. So we would take our 26,990 square inches, and we could use this conversion factor here. We would have 1 square yard all over 1,296 square inches. The square inches will simplify out. It'll be 26,990 over 1,296 square yards. And that would give us an approximate answer after rounding to 2 decimal places of 20.83 square yards. Now, we move on to the next page. Problem number 6. It says, to understand the significance of question 4 and 5, let's suppose we didn't have the conversion factor for converting square inches to square yards we developed in question 4. Another way to say square yards is yards times yards, and square inches is equal to inches times inches. With that in mind, it says if we multiply the total square inches you use in question 5 by the conversion factor 1 yard over 36 inches, what sort of units will remain? Try it, don't just guess. Now these here are to assist you in your quest to get the correct answer, which we already got in the previous problem, but let's take a look. So we'll take 26,990 square inches and multiply it by this conversion factor, which is 1 yard over 36 inches. Now, this will be over 1 inch and inch squared. Inch to simplify out. Inch squared will simplify out and just leave you an inch. So you add 26,990 over 36 yards. And then when you put this in your calculator, it'll give you 749.72 inches times yards. Now it says, what if we multiply that result by 1 yard over 36 inches again? So we would have 749.72 inch yards multiplied by 1 yard over 36 inches. The inches will simplify each other out, and we will multiply this. It'll give us 749.72 square yards over 36, and that'll give us approximately 20.83 square yards. And we ended up with the same answer that we had in problem number 5. Okay, now we go down here to number 8. Now it says, now let's use some estimation skills to see if your answer to question 5 and 7 is reasonable. Because if it's way off, that'll totally mess up the rest of this activity. The bulk of the area comes from the bedroom, right? Find the length and width of the bedroom in feet, round it to the nearest foot. Then divide by 3 to convert to yards. Again, round it to the nearest yard. Finally, use these measurements to get a rough guess of the bedroom area in square yards. If you have the wrong conversion factor in question 4, or did the conversion wrong in questions 5 through 7, the number of square yards you got will probably be radically different from the estimate in this question. If so, figure out what you did wrong in 4 and or 5. Okay, so first things first, we need to Okay, when you go back to question 1, you notice that our length and width 171 and 138. So we have 171 inches, 138 inches, and then we had, well, first let's take care of those. So we have 171 times 1 feet over 12 inches. The inches will simplify each other out, and that would give us 171 over 12 feet, which is 14.25. Now, when you round this to the nearest whole number, it'd be 14 feet. Now, if we take this 138 inches and multiply by 1 feet over 12 inches, the inches will simplify out, and it'd be 138 over 12 feet, which is equal to 11.5 when you put in your calculator, which rounds to about 12 feet. Now, the next thing we want to do is change these feet to yards. So we will have 14 feet and 12 feet. So we'll multiply this by 1 yard over 3 feet. The feet will simplify out, be 14 over 3 yards, which is approximately 4.67, which rounds to 5 yards. And that's yards. Okay, next, we'll multiply this 12 feet by 1 yard over 3 feet. The feet will simplify each other out, and it'd be 12 over 3 yards, which is equal to 4 yards. And we don't have to round that. So now, if we do the area of the estimate, this is length and width. So the area would be 5 yards times 4 yards, which is 20 square yards. And as we know in our previous answer, if you look back up at problem number 7, it's 20.83 square yards, and this is 20 square yards. So they're basically very close. So it turns out that that was a good estimate. Now, we go on to problem number 9. Now, with problem number 9, it says write a sentence or two describing how the professional estimate compares to the actual carpeted area. Use your answer from question 7. Now, the actual area, if you look back at number 7, it was about 20.83 square yards. The estimate area, the estimated area, was 24.67 square yards. Now let me show you where we got that 24.67 from. It was actually back on problem, the directions for problem number 1. When we had the estimate that it was 24 and 2/3 square yards, so we wrote that as a decimal, which would be 24.67 square yards. So that's where we had got that estimate from. Okay, so now, if we look here, the actual area and the estimated area, the estimate is almost 4 square yards higher than the actual. Now, number 10, it says find the relative difference between the estimate and actual area of the carpeted portion of the room. Round to 2 decimal places. Write a sentence explaining what this tells us about how the estimate compares to the actual carpeted area. Writing the relative difference as a percentage is a good idea. Okay, so we have the relative difference. We know that's the estimate minus the actual divided by the actual. The estimate was 24.67. The actual was 20.83 divided by 20.83. So that would give us 3.84 divided by 20.83, which is equal to 0.18, which is 18%. So the estimate is 18% more than the actual. Number 11. Now, everyone realizes this, but when you buy carpet, you pay for the estimated amount, not the actual amount covering your floors. If the family that owns the house in the diagram picked carpet that costs $28 per square yard installed, how much would they pay? So if we took the estimate, which is 20.67, and multiplied it by 28 per square yard, that would give us $690.76. That's how much it would cost us to carpet using the estimate. Now, it says for number 12, use the actual difference between the estimate and the carpeted area to find the dollar value of wasted carpet. Now, we already figured this out. The actual difference would take the estimate minus the actual, which would give us 3.84 square yards. Now we want to find, this is how much overage you're paying. So you would pay 3.84 times 28, which would give $107.52 extra you're paying. That's why a lot of times when you see people that carpet their homes, they always have a lot of carpet left over. Okay, now we're moving on to problem 13. It says, suppose that one transformer is designed to handle a maximum of 2.4 megavolts, and it has the ability to handle a 15% overage. If the voltage spikes at 2.91 megavolts during a power surge, can the transformer handle this? Show your work. Okay, so what we would do is this here. Let me see. We got 2.91 and 2.4. So what we need to do is find the increase, the relative increase. Because remember, the maximum is supposed to be 2.4, but it can handle a 15% overage. But the new value is 2.91. So what we would do is we would do percent increase. Now with the percent increase, remember it's the new minus old divided by old, or new minus original divided by original. So the new value is 2.91 minus the old value, or original value, is 2.4 divided by 2.4. Now when you put this in your calculator, it will give you the decimal of 0.2125. Now when we write that out as a percent, it'll be 21.25%. So the transformer cannot handle this. Because remember, it can only do a 15% overage. This was 21.25% over, so it can't handle it. So now 14. Based on question 13, it would seem to be a natural question to ask exactly how many megavolts the transformer can handle without sustaining damage. We can use some algebra in the calculation above to figure that out. Using the variable V for the voltage and 0.15 for the relative error, set up and solve an equation that tells us the voltage that corresponds to a 15% overage. Okay, so this is what we would have. We had V as the voltage. So this is the voltage we don't know, or the new voltage. minus the original value divided by the original value, and it must equal 0.15 or the 15%. So the next thing that we would do is this here. We could multiply everything by 2.4. We multiply everything by 2.4, that would get rid of this denominator, and we have v minus 2.4. 2.4 times 0.15 is 0.36. You add 2.4 to both sides, and the voltage can be 2.76 megavolts. That's the highest that it could go. Okay, number 15. It says list some situations where relative difference is a much more useful number than actual difference. Be creative. Okay. Relative difference. Losing $1,000 is a really big deal to me, but for Bill Gates, it is not that high of a percent to be a big deal for him. And number 2, getting shorted 5 minutes on a 30-minute massage is a large portion compared to being shorted 5 minutes on a 2-hour massage. And that is it from this section. And if you have any questions, please email me, or you can wait to the big blue button and we could discuss it then. Have a nice day.